LM2267X step-down voltage regulators from National Semiconductor. Welcome to the training module on National Semiconductor's LM2267 family of step-down voltage regulators. The intent of this training module is to study the functionalities and application of the LM2267 family of buck regulators. From the figure, we can see that the output voltage is stepped down by modulating the duty cycle of the MOSFET Q1. When the MOSFET turns on, VIN is applied to the LC output filter. The transfer function of this regulator is Vout equals D times Vin, where D is the duty cycle of the modulation switch Q1. The diode D1 provides a path for the inductor current to flow when Q1 is turned off. Each cycle, the inductor current ramps up while Q1 is on and then ramps down while the diode is conducting. The MOSFET and diode currents sum to form the inductor current. The simple switcher concept provides for an easy-to-use complete design using a minimum number of external components from National's WebBench design tool. National's WebBench tool features such as an external component calculation, electrical simulation, thermal simulation, and build-it boards for easy design-in. The switching clock frequency is provided by an internal fixed frequency oscillator which operates at 500 kHz. The switching frequency can also be adjusted with an external resistor or synchronized to an external clock up to 1 MHz. It is also possible to self-synchronize multiple regulators to share the same switching frequency. The LM2267X simple switcher step-down regulator series is the next generation of the highly popular LM267X simple switcher regulators. Numerous enhancements and improvements have been added, such as an input range down to 4.5 volts, tighter output accuracy, adjustable switching frequency, a precision enable pin, and thermally enhanced green packages. These new simple switcher regulators, together with WebBench Power Designer, provide fast and easy design-in while delivering performance and flexibility to meet your design and application requirements. The LM2267X switching regulators feature all of the functions necessary to implement an efficient, high-voltage buck regulator using a minimum of external components. This integrates a 24-volt in-channel switch with an output current of up to 5 amps. The regulator control method is based on voltage mode control and with input voltage feed forward. The loop compensation is integrated into the LM2267X so that no external compensation components need to be selected or utilized. The operating frequency is fixed at 500 kHz to allow for small external components and avoid excessive switching losses. The switching frequency can be adjusted with an external resistor from 200 kHz to 1 MHz, or it can be synchronized to an external clock up to 1 MHz. The table provides a quick selection guide for the LM2267X family of simple switcher regulators. The precision enable pin can be used to shut down the power supply. Connecting this pin to ground or to a voltage less than typical 1.6 volts will completely turn off the regulator. The enable pin has an internal pull-up current source of approximately 6 microamps. When driving the enable pin, the high voltage level for the on condition should not exceed the 6-volt limit. When enable control is not required, the EN enable pin should be left floating. The precision feature enables simple sequencing of multiple power supplies with a resistor divider from another power supply. When the power switch turns on, the slight capacitance loading of the Schottky diode D1 causes a leading edge current spike with an extended ringing period. This spike can cause the current limit comparator to trip prematurely. When the switch current reaches the current limit threshold, the switch is immediately turned off and the internal switching frequency is reduced. This extends the off time of the switch to prevent a steady-state high current condition. As the switch current falls below the current limit threshold, the switch current will attempt to turn on. The soft start feature allows the regulator to gradually reach the initial steady-state operating point and reduces startup stresses and surges. The soft start can be adjusted by an external soft start capacitor. If no external soft start capacitor is used, there is an internal soft start feature with 500 microseconds typically. There are 3 different modes for the RT sync pin. It can be left floating for a 500 kHz switching frequency. A resistor from the RT sync pin to ground can be used to adjust the switching frequency between 200 kHz and 1 MHz. An external sync pulse can be applied to the RT sync pin for switching frequencies up to 100 or 1 MHz. The LM2267X integrates an in-channel FET switch and associated floating high voltage level shift gate driver. This gate works along with internal diode and external bootstrap capacitor of 0.01 microfarad ceramic cap. Internal thermal shutdown protection protects the LM2267X in the event of the maximum junction temperature is exceeded. When activated, typically at 150 degrees C, the regulator is forced into a low power reset state. The typical max duty cycle is 85% at 500 kHz switching frequency. This corresponds to a typical minimum off time of 300 nanoseconds. When operating at switching frequencies higher than 500 kHz, the 300 nanoseconds minimum off time results in a lower maximum duty cycle limit than 85%. Besides a minimum off time, there is also a minimum on time, which will affect the output voltage is adjusted very low and the input voltage is very high. Inductor L1 is determined, its value is determined based on the load current, ripple current, and min-max input voltage. Input capacitor C1, this is used to limit the ripple current at the VN pin while applying most of the switch current during on time. Output capacitor C4, this limits the output ripple voltage and provides a source of charge for transient loading conditions. Boot capacitor C3, the bootstrap capacitor between the boot pin and the SW pin supplies the gate current to turn on the in-channel MOSFET. Resistor divider. For negative adjust option, no resistor divider is required for 1.285 volt output. For other voltages, negative adjust option can be used with the resistor divider. Catch diode D1, a Schottky diode which has ideal reverse recovery characteristic and low forward drop is required. The most important printed circuit board layout rule is to keep the AC current loops as small as possible. The schematic shows the current flow of a buck converter. The stop schematic shows a dotted line which represents the current flow during the FET on switch. The middle one shows the current flow during the FET switch off state. The bottom one shows the current referred to as AC current. These currents are the most critical since it is changing in very short time periods. The dotted line in the schematic are the traces to keep as short as possible. This will yield in a small loop area, reducing loop inductance.